Hi guys, Audrey here. Let's do group work 5. So I actually already have all of the answers written down for us, but I'm going to talk through and just kind of like point out a couple things that people really have trouble with in terms of this stuff. So the first thing is we're doing the derivative of cotangent of x over 2 plus sine of x. This x over 2 right here, it's important to understand that this doesn't need a quotient rule or chain rule or anything like that. X over 2, oops, let's do this in green. X over 2 is actually just the same thing as 1/2 x. So in other words, it's actually just a constant times x. So if I'm doing the derivative of x over 2, that's the same thing as doing the derivative of 1/2 x. And so it's just 1/2. In the same way that the derivative of 2x is just 2, the derivative of 5x is just 5. So with that said, when I'm doing the derivative of cotangent x here, I have a chain rule. The derivative of cotangent is negative cosecant squared, and then I have to multiply by that negative, or by that 1/2 on the outside, or I can multiply by it at the end because I'm doing the chain rule. The derivative of sine is just cosine, no chain rule is needed there. Okay, so then because I'm asked to find the equation of the tangent line, I now have to plug pi over 2 into this thing. So in order to do this, I'm just going to remind us really quickly of our table of values that we have for trig functions. So we know that the values that we know about are pi over 6, pi over 4, pi over 4, pi over 3, pi over 2, and then pi. I unfortunately forgot a column here for 0, so we also are going to have a 0. And then we can actually easily figure out the values of sine x and cosine x at these places. So I know that sine starts at 0, and then it's just increasing by 1. So it's like 0, I can think of that as 0 over 2, and then 1 over 2, and then root 2 over 2, and then root 3 over 2, and then root 4 over 2, which is actually just 1. So sine starts at 0 and then goes up to 1, and then it starts going back down, and by the time it gets to pi, it's actually back at 0 again. So we can just put a 0 there. And cosine is the same, except it goes the opposite. It starts up at 1 and it's going to go down. So cosine starts at root 4 over 2, which is 1, and then it'll be root 3 over 2, and then root 2 over 2, and then 1 over 2, and 0. And when it gets to pi, cosine is actually at -1. So those whole numbers at 1/2, the 0, the -1, your calculator will give you those as long as you have it in radians. But for things like root 2 over 2, we have to be a little bit more creative about how we find them, I guess. So the first thing that I'm trying to do is cosecant squared of pi over 4. So really this is cosecant squared. My x is pi over 2 over 2, which is cosecant squared of pi over 4. So for cosecant, we're going to have to use our trig identity, and this gives us 1 over sine squared of pi over 4. So because I know that cosecant is equal to 1 over sine, so cosecant squared is 1 over sine squared. Because it's sine squared of pi over 4, that pi over 4 comes down with me. And this gives me 1 over, well, sine of pi over 4 is root 2 over 2. So I'm just squaring that. So it's 1 over root 2 over 2 squared. So this gives me 1 over 2 over 4, which is actually just equal to 2. So when I plugged in, notice I was able to, well, the way I did it was I saw that that was equal to root 2, but this also works. So it's just -1/2 times 2, same thing that we have right here, -1/2 times 2, and that gives me a -1. The cosine of pi over 2 is actually just, if we go and we look here, we can see that cosine of pi over 2 is just 0. And so technically it's like I have a +0 in there. So then my slope is -1. Now, if I want to think about cotangent of pi over 4, well, cotangent is just cosine over sine. So again, these are just kind of identities that we know. You could also do 1 over tangent and plug this into your calculator. But here I can see that cosine is root 2 over 2 at pi over 4, and sine of pi over 4 is also root 2 over 2, so this is just equal to 1. And then I can use my chart directly to see that sine of pi over 2 is 1. So that gives me that my slope is -1, my point in question is pi over 2. I plug those into my line here to get the 2 is equal to negative pi over 2 plus b. So b is just 2 plus pi over 2, and that gives me my tangent line. Now I want to point out that 2 plus pi over 2, if I combine it, does not equal to pi. It's not 2 pi over 2. I could say this is equal to 4 over 2 plus pi over 2. And this is actually equal to 4 plus pi over 2. I can't multiply those things together. So be careful about things like that. That 2 plus pi over 2, it's probably best just to leave it like that. Make sure you do not give me a decimal. Decimals are evil. Okay, next question. So this is one that a lot of you really struggled with. Notice the first thing that I did here is that power of 3 that I have right there. I moved it to the end. And the reason that I did that is because it allowed me to really easily see that what I actually have going on here is g cubed. And if I think about the derivative of g cubed, we know that's 3g squared times g prime. So that's why when I bring that 3 down front, that cosine is repeated. So I bring the 3 down, cosine of secant of 1 minus x squared times the derivative of cosine of secant of 1 minus x. So that's my first chain rule, and it leaves me with the 3 cosine squared. Now the derivative of cosine is negative sine. I pull out the derivative of secant of 1 minus x. The derivative of secant is secant tangent. I pull out the derivative of 1 minus x, which is -1. So this is why we have that 3 cosine squared in the beginning. Notice I also just took that negative and moved it to the front. All right. So this next one was a pretty straightforward question. It was just a question of recognizing that we had to do a product rule. This is e to the 5x squared plus 4 times tangent of 3x to the 4th. So I can insert the word times in there, times tangent of 3x to the 4th. So then that means I just have a product rule that I need to do. And we know that product rule is f prime g plus f g prime. So in each of these, the e to the 5x squared plus 4 and the tangent of 3x to the 4th, I have a chain rule to do. So I'm just pulling out the derivative of 5x squared plus 4 and the derivative of 3x to the 4th to get my final answer here. So I did my product rule, and inside my product rule, I had 2 chain rules. Next. All right, so this one is actually just a really simple quotient rule, and I think most of you got this one right. So my quotient rule, remember, is f prime g minus f g prime over g squared. So that's something I'm expecting you guys just to know by now on your group work. If you didn't get it, you definitely lost a point for effort. You should just know it. If not, you can always look in your notes and find the quotient rule, but you should definitely have this memorized. So I have the derivative of the top times the bottom minus top times the derivative of the bottom over the bottom squared, and both of these also require a chain rule. The cotangent one is a really small one. I just had to pull out the derivative of 8x, which is just 8. For 3 to the 4x plus 9 as well, I just had to pull out the derivative of 4x plus 9, which is just 4. Other than that, these are just the functions directly placed into the chain rule. The quotient rule. All right, so that's C, which brings us to this last one, which should have said f of x. I'm sorry, not f of g. Now this last one, actually you guys did really well on. I was super impressed. The first thing I want to do though is the same thing I did in the first one, actually, the cosine cubed one, is I have a trig function to a power. So I'm going to take that power and move it to the end, which allows me to see that what I actually have here is g to the power of 5, where g includes that sign. G is sine of the square root of cosecant of tangent of 3x squared minus 4. And we know that the derivative of g to the 5th is 5g to the 4th times g prime. So that's why here I brought the 5 down, I subtracted 1, and then I pulled out the derivative of that sign. Now that sign also is going to require a chain rule because it's sine of a function. So the derivative of sine is cosine. Then the thing I'm pulling out here is the square root of cosecant of tangent of 3x squared minus 4. And what that means is that this g right here, this cosecant is like a g to the 1/2. So first I'm bringing the 1/2 down, I'm not touching the cosecant, I'm subtracting 1, and then I'm pulling out the derivative of cosecant. So you'll notice in the next step, I have 1/2 cosecant of tangent of 3x squared minus 4 to the negative 1/2 times the derivative of cosecant of tangent of 3x squared minus 4 to the 1 minus 4 with no power there. So now this is also important. The derivative of cosecant is negative cosecant cotangent, where cosecant and cotangent are both being evaluated at the same place. So notice here, I'm going to highlight this. This negative cosecant cotangent, it looks like I put a negative twice and I should not have. So this is negative cosecant cotangent, and both of those negative cosecant and that cotangent are being evaluated at tangent of 3x squared minus 4. And then I'm pulling out the derivative of tangent of 3x squared minus 4, which is secant squared of 3x squared minus 4 times 6x. So that's another chain rule in itself. Good, I didn't write the negative twice. Good. So anyway, these started off with that 5g to the 4th. Now the last one, hi prime. Many of you told me that it's hello or heya. Why don't we say that it's yo? That one was an accident. You don't have to worry about that. Anyway, so that is your group work 5, and those are kind of the things that people struggled with. The main thing that I want you guys to take away from this is really that when we have that power of a trig function, that power needs to move to the end and create the first chain rule. So 5g to the 4th times g prime here, and 3g squared times g prime here. All right, that's all. Bye, guys.